Welcome to day 4 of my 14-day SAT prep series. In today's video, I'm going to be doing some of the mid-difficulty to upper difficulty math problems of the math no calculator section, and then some of the mid-difficulty to upper difficulty problems of the math with calculator section. After that, I'm going to get into some math tips, and then I will go through a reading passage very slowed down with you. So I'll be really going slow, trying to give you some of my advice for the reading section, tips, tricks, how I approach questions, what I look for in passages as I read through, and things like that. Then after that, I will conclude with some reading tip videos as well. So hopefully this video will be helpful. If it is, make sure to like, subscribe, and share. And with that, let's go ahead and get started with questions 11 through 20 from SAT Practice Test 10. So yesterday we did problems 1 through 10 of the math no calculator section. Today we're going to be doing problems 11 through 20 of the math no calculator section. So obviously the questions get more difficult as you move on from 1 through 15 and then from 16 through 20. So these will be a little bit harder than yesterday's, but that'll be perfectly fine. And let's go ahead and get started with 11. A circle in the xy plane has center 5, 7 and a radius 2. Which of the following is an equation of the circle? Well, we know our equation of a circle is x minus h squared plus y minus k squared equals our radius squared, where our center is HK. Okay, you'll remember that from our equations video where we talked about the math formulas on, I believe it was day 1. In this case, we see that our center is going to be 5, so we just put in 5 for H. We got x minus 5 squared. We see that we can go ahead and get rid of D and get rid of B, and then we have a 7 for our Y value. So we can go ahead and put Y minus 7 squared, or y minus 7 squared right there. Find our answer choice that matches that. We see that we've got 2 of them so far. Next thing we see is that our radius has to be squared. Our radius is 2. What is 2 squared? Well, we know that 2 squared is going to equal 4. Okay, so our radius then must be 4. We get rid of C and we see that we have answer choice A as our correct answer. Now we can go ahead and move on to question 12. So as far as tips for this one, it's really just understanding the equation of a circle is all you need to know for number 11. Number 12, okay, right off the bat, I see that we're going to end up having similar triangles. I'm told triangle ABC is similar to triangle DEF. I'm asked for the value of cosine E. Okay, the value of cosine E is going to be the same as the value of cosine B, since those are going to be the same angle, right? We see that they're going to be the same angle measure since these are similar triangles. So value of cosine E, we know the value of the cosine is the same as the cosine. If we use our SOHCAHTOA, we know that the cosine is our adjacent over our hypotenuse. We see at angle B, our adjacent is 12 and our hypotenuse is 13. Thus, our cosine of E is going to be 12 over 13. Okay, the same as cosine B since they're similar triangles. So our correct answer there is going to be 12 over 13. Correct answer is going to be B for that one. So key things you need to know in order to answer this problem. Similar triangles, values of their cosines, sines of the same corresponding angle. In this case, the corresponding angles are B and E. They're going to be the same. Other thing that you need to know to answer this is what cosine is. That's going to be your adjacent over your hypotenuse. So 12 over 13 in this case. Okay, if you know those, then this problem was going to be pretty easy for you. All right, next thing we got question 13. In the xy plane, the graph of the function f of x equals x squared plus 5x plus 4 has 2 x-intercepts. What is the distance between the x-intercepts? Okay, key thing here is paying attention to the end of the question. We're asked for the distance between the x-intercepts. So what I'm going to look to do here is factor. Okay, so I have x squared plus 5x plus 4. So I know I'll have an x there multiplied by an x here to get me that x squared term. Next thing I'm looking at are what are the factors of 4 that add to 5. The factors of 4 that add to 5 are going to be 1 and 4. So I'll have to have x plus 1 and I'll have to have x plus 4. Okay, so that's going to be my factoring. Then I take my x plus 1 and I'll set it equal to 0. X plus 1, I'll set it equal to 0. I'll take my x plus 4 and I'll set it to equal to 0. Then I'm going to obviously see that when I subtract 1 from each side, I'll have x equals 1, and when I subtract 4 from each side, I'll have x is equal to negative 4. Keep in mind, 1 and 4 aren't my answers here because I'm asked for the distance between the x-intercepts. So my correct answer is the distance between negative 1 and negative 4, and that's going to be 3. Okay, so key things for this problem. Understand that we want to factor this out rather than using the quadratic formula, or I'm sorry, I believe that, yeah, the quadratic formula, because that's going to take us much longer than just factoring. So we factor out, we set it equal to 0, find our correct answers, find the distance between the two. That's the fastest way to do this one. Now, one thing I do recommend is that when you see that you have x plus 1 and you have x plus 4, one thing I recommend is if you can skip this middle part that I'm going to put in red, if you can skip that part, now obviously you have to do it in your head, but if you can just recognize that you have x plus 1 and immediately know that x is going to equal negative 1 and that x is going to equal negative 4 just by looking at this and at this, that's going to help you save time on the math section, and that's something I recommend doing. Okay, so anytime you can save time because you just know something like x plus 1 when you set it equal to 0 will equal -1, that's going to save you time. I recommend doing it. All right, so that's going to be C is going to be our answer for 13. That one right there, also not too difficult. Now we got 14. So we have the square root of 4x equals x minus 3. What are the values of x that satisfy the given equation? Okay, in this case, one thing that I'm going to say right off the bat is if you have two numbers like this, right, and you're just asked to find which ones work or which one satisfies the given equation, and there's only two of them, I have zero problem with you plugging and chugging. If there's only two answers that you have to plug and chug to check, I have zero problem with you checking them. So I wouldn't even go through the effort of squaring this and then trying to go and solve for x, because if there's only two of them, honestly, it's going to be probably quicker for you just to substitute in, especially since the equation is this simple and we only got to substitute x at two spots. So in this case, I'm going to go ahead and substitute 1 in. I got the square root of 4 times 1. I know 4 times 1 is 4. Square root of 4 is 2. Next up, I see that if I have 1 minus 3, I know that that's going to equal -2. Now, does 2 equal -2? It does not. Therefore, 1 is not my answer. I can get rid of any answer choice that has 1, so I can get rid of A and I can get rid of C. I see now I have to test for number 2. Number 2 says 9. What's the square root of 4 times 9? Well, that's going to equal the square root of 36, since 4 times 9 is 36. Square root of 36 we know will equal 6. Next thing we have is x minus 3. So what about 9 minus 3? Does that also equal 6? We see that it does also equal 6. Thus we have 6 equals 6, right? We see that that is correct. Thus our answer will be answer choice B for 14. So key things here, if you only have two numbers, I have no problem with you plugging and chugging because that's going to be pretty quick. So zero issue with that. Other key thing to notice is that when we take the square root of a number, right, and we get something like 2 and we're taking the square root of 4, if that's set equal to the negative version of that, like -2, that's not correct. Okay, that does not satisfy that equation. So you got to understand that, because oftentimes they will put something like a 1 here just to test that you understand that 2 doesn't equal -2. Okay, so you got to understand that for the SAT math section. All right, question 15. Oh yeah, I like these questions, and I'll show you why right here. So we have in the system of equations above, and I believe you saw this tip yesterday in yesterday's video dealing with canceling variables. So I'm asked for which values of A does the system have no solution. All right, so what I'm looking at here is I see I have a -3x, a y, and it's set equal to 6. Okay, in this case I have a 4 there, an A of x, and a plus 2y. In this case, I'm asked for the value of A that has no solution. So what I'm going to do is I understand in order for something to have no solution, since both of these are linear formulas, I need to have parallel lines with different y-intercepts. Okay, so I got to have parallel lines with different y-intercepts. Then they're going to have no solution. Now I see that if I have the same slope, which you have to have in order to have parallel lines, you must have the same slope, so the same ratio of x to y, you have to have the same ratio. I see that I already have a 6 and a 4, so I know I'll have different intercepts as long as my slope is the same. So what I'm going to do here is I see that I have a y and I have a -3x. And then in this bottom one, I see, I'll put it in blue, I have 2y. So I doubled my y, thus, in order to keep that same ratio, I have to double this -3. So I doubled my -3. -3 times 2 is going to give me -6 as the value of A. So my correct answer there will be A. So understand a couple of things in order to get this one correct. Or hang on a minute. Yeah, my correct answer there is going to be A. So the big things here that you need to understand in order to answer this question correctly are going to be that you've got parallel lines. It means you have the same slope. So if the lines are parallel, you got the same slope. If they have a different y-intercept, there's never going to be a solution. So you have no solution. Other things that you should just know, and this isn't on this problem, but if you have perpendicular lines, if you've got perpendicular lines, go ahead and draw some. If you've got perpendicular lines, it just means there's a 90 degree angle there, and that means that your slope of one line is going to be the opposite sign reciprocal. So let's say that the slope of this line was, we'll say 1/2 x. Okay, well then the slope of this line going down, I'll put it in red. Slope of this line then, since it's a perpendicular line, then has to be the reciprocal with the opposite sign, so -2x. Okay, so you see that we flip that 2 and that 1, we flip them around, and then we also change the sign from a positive to a negative. So that's how you deal with perpendicular lines as well. So I just wanted to add that in there. All right, so now we can go and move on to the free response section. Now what you'll notice is that there's a drop in difficulty from questions 13 to 15 and even 12 and 11 of the multiple choice to the beginning of the free response, as you'll see here. So we're told the manufacturer shipped units of a certain product to 2 locations. The equation above shows the total cost T in dollars for shipping C units to the closer location and shipping F units to the farther location. If the total shipping cost is 47,000 and 3,000 units are shipped to the farther location, how many units are shipped to the closer location? So in this case, we're given what F is equal to, what T is equal to, and we're asked to solve for C. So we know that T is going to be 47,000. We know that we have 5C, we're not told what C is, and we have plus 12 times the units sent to the farther location, which is 3,000. Okay, so first thing we're going to want to do here is what is 12 times 3,000? Well, that's going to be 36,000. Okay, so we can go ahead and subtract then 36,000 from each side, try to isolate 5C. That'll cancel out. Subtract 36,000 from each side. That's going to leave us with 11,000 equals 5C. So we'll have 11,000 equals 5C. At that point, to solve for C, we divide each side by 5. 11,000 over 5 we know will equal 2,200 as our answer for C. So 2,200 will be our answer there. So that one right there, things that you need to know is how to set up these equations, right? So you have your equation, you just got to understand, you got to plug in your numbers and then solve from there. So that one's really just dealing with algebra. Next up, this one right here is something you should know. We've got if A and B are the solutions to the equation above, what's the value of A minus B? So key thing here, paying attention to the end of our question. Once again, we can't answer with the value of A, and we can't answer with the value of B. We have to answer with the value of the absolute value of A minus B. So paying attention to what you have to answer with, otherwise you're going to get this wrong. So what we're going to do here, we have 2x plus 1 and absolute value bars equals 5. In order to solve this, we also have to set it equal to negative 5. At this point, we just go through and solve, right? So I'll go ahead and set up my two equations. I have 2x plus 1 equals 5, and then we'll have 2x plus 1, and I'll write it on the other side. Put it over here. 2x plus 1 equals negative 5. So we got to solve for what x equals in both of these. So we'll subtract 1 from each side, subtract 1 from each side. We get 4 equals 2x. Obviously, then when we divide each side by 2, we're going to end up with 4 over 2, which is x equals 2. Now, looking at our other equation, when we subtract 1 from each side, we're going to end up with negative 6 equals 2x. Negative 6 equals 2x. Thus, when we divide each side by 2, we're going to end up with x equals negative 3. Okay, so it doesn't matter which one we pick as A and which one we pick as B here, but we do have to put it in absolute value bars. So we'll just call x equals 2A. So we'll have 2 as A, and then we go minus B, which will have minus negative 3. Put it in absolute value bars. That's going to be 2 plus 3 since it's minus a negative, which will give us 5 on absolute value bars. So our answer there is going to be 5. Key things to understand here. When you've got an absolute value set like this, or an absolute value where you have a variable in the middle and you've got to solve for that variable, and there's two solutions like this, what you got to do is you got to set it equal to the number like it is here, and then also to the negative version of that number, which in this case would be negative 5. So those are the big things you need to understand for question 17 in order to get it right. All right, question 18. Juan purchased an antique that had a value of $200 at the time of purchase. Each year, the value of the antique is estimated to increase 10% over its value the previous year. The estimated value of the antique in dollars 2 years after purchase can be represented by the expression 200A, where A is a constant. What's the value of A? Okay, this right here. This is going to be growth, where we have an initial value of 200, and we know we're increasing by 10% each year. Okay, we have to raise it to the number of years, that 1.1. That increase of 10% is represented by a 1.1, and we know that we have to square it since it takes place over 2 years, right? That 1.1 occurs on year 1 and then also year 2. So we have to multiply by 1.1 2 times, thus squaring that 1.1. Now, keep in mind, we have to answer with the value of A here, so 200 times whatever A is. So we know that A is going to be 1.1 times 1.1. We know that that is going to equal 1.21. Thus, our answer is 1.21. Now, we got to remember, we don't multiply by 200 here. Once again, very crucial to pay attention to what you have to answer with. Okay, if you're not paying attention to what you have to answer with, you're going to end up getting these questions wrong. Okay, if you don't pay attention to what you're asked at the end of the problem, you're going to get a lot of questions wrong on the SAT math section. All right, number 19. Okay, this one right here, I talked about this tip yesterday. You'll see it on here right now. We have, based on the system of equations above, what's the value of 5x plus 5y? Okay, look at this. When I see I have a setup like this, 5x plus 5y, what do I see immediately? I see if I add 2x to 3x, that gives me 5x. If I see I add 3y to 2y, that gives me plus 5y. Now I see I add 1200 to 1300, that's going to give me 2500 as my answer. Okay, because I'm asked for the value of 5x plus 5y. Answer is 2500. That one right there, pretty easy as long as you know the trick of adding and subtracting and things like that when you have a stacked equation. So anytime you see stacked equations like this on the SAT math section, you should be really excited because you should know that you can solve that question fairly easily and fairly quickly by using that trick. of adding and subtracting and things like that. So 20. If u plus t equals 5, u minus t equals 2, what's the value of u minus t? U squared minus t squared. This right here should be a big time flag, right? And it's not a red flag, it's really a green flag, or an excited flag, because when you see u squared minus t squared, you should be thinking difference of perfect squares. So difference of perfect squares, let's go ahead and go through that. Difference of perfect squares. So we see that we've got u squared minus t squared. Well, what is that equal to? That's equal to u plus t times u minus t, right? Because if we do that, we got u plus t times u minus t. We see that when we do that, we're going to end up with u squared. We'll have this minus t squared, and then this plus t times u. We'll have plus tu, but then we'll have minus tu going this way. So those will cancel out, and we'll be left with u squared minus t squared. Thus, what we can do is we can take this 5, we can multiply it by 2, to give us 10 for that u squared minus t squared value. Thus we have 10 times this u minus t, which I'll put in red. Okay, this u minus t, which we know is equal to 2. Thus we have 2 times 10, giving us our answer of 20. So 20 will be our correct answer there. Okay, that one, understanding difference of perfect squares, really helps you move through that one a lot faster. All right, moving on to the math with calculator section. Like I said, today's video is going to be a little bit longer than normal, just because we want to cover a little bit more material today. All right, so now we got question 11 is where we left off last time. So the first thing I see when I look at question 11 is I see that I've got a table with 2 rows, list A and list B. The table shows 2 lists of numbers. I'm asked for which of the following is true comparing list A and list B. So I look at my option A. I have the means are the same and standard deviations are different. I see I'm comparing means and standard deviations in all of my answer choices A through D. So what I'm going to do is I'm going to find what my means are, my standard of deviations. I'm going to find my correct answer by solving for those. So if I take a look at these, I see I have the same amount of numbers in each one. So I got to find my totals, and whichever one, if their totals are the same, it means their means are the same. If their totals are different, it means their means are going to be different. So I'm going to go ahead and add my first row. I've got 1 plus 2 plus 3. I see I've got 6 at that point then. 6 plus 4 is going to give me 10. 10 plus 5 will give me 15. 15 plus 6 will give me 21 as my total for all of those. Now I look at my bottom row. I got 2 plus 3. That's going to give me 5. Now I got 5 plus 3. It's going to give me 8. 8 plus 4 is going to give me 12. 12 plus 4 is going to give me 16. 16 plus 5 will also give me 21. Thus, our means are going to be the same since we're dividing by the same amount of numbers in each one. So I can get rid of C and D. Next thing I'm looking at are standard of deviations. Standard of deviations, you don't have to calculate here. You just have to understand how standard of deviations work. So since these both have the same average, whichever one has a greater deviation from that average is going to have a greater standard of deviation. Now in this case, we don't have to know which one's greater. We just have to know if they're different or the same. Obviously, they're going to be different since we have greater standard of deviation in this list A, right? We have more of a deviation from that mean of 21 over 6 than in list B. We see in list B they're a lot more concentrated around that 3 and 4. So our correct answer is going to be that the standard of deviations are different. Thus, our correct answer for 11 will be A. All right, let's take a look at question 12. So we have a book was on sale for 40% off its original price. If the sale book price was $18, what was the original price of the book? So we know our $18 is equal to our 1 minus that 0.4. Okay, so we got 40% off times our original price of the book, which we will call P for original price. So all we got to do here is we just got to divide each side by that 1 minus 0.4, which we know is just going to equal 0.6. Okay, 0.6. We do that, that's going to cancel right there. We're going to be left with our original price of our book as 18 over 0.6. We plug that in our calculator, which I'll do right now. And we believe that that's going to give me 30, and it will give me 30 as my correct answer. So C will be my correct answer there. So that one, not too bad either. All right, moving on, we got question 13 and 14, and we see that that's a paired question set according to this graph. We've got 3 colonies. I look at my options on my axes. I've got number of insects as my y-axis, weeks after initial treatment x-axis, and then I've got my 3 colonies represented as well. I'm told that this is the insect count for 3 pesticide treatments. When I'm looking at graph questions, I always want to look at my axes and my titles as well as what each bar graph represents. So I have 3 colonies of insects were each treated with a different pesticide over an 8-week period to test effectiveness of the 3 pesticides. We've got colonies A, B, and C treated with different pesticides respectively. Each pesticide is applied every 2 weeks to one of the 3 colonies of the 8-week period. Bar graph above shows insect counts for each of the 3 colonies after different numbers of weeks after the initial treatment. So I'm asked which of the following colonies showed a decrease in size every 2 weeks. So every 2 weeks, it's got to be consistent. after the initial treatment with pesticide. I've got counties A, B, and C. Well, if I take a look, I go ahead and see I have a big jump in colony C from 0 to 2. So I know colony C can't be a correct answer here. So I can go and get rid of any answer choices that have 3 in it. Okay, so I can get rid of B, I can get rid of D. Next thing I'm looking at is 1 versus 1 and 2. I see 1 is in both those answers, so I'm going to check 2. If I check 2, we see that 2 is colony B, obviously. So colony B is going to be this dotted one. I see I go down, and then I go down again, and then I go down again, and then I go down again as well. Okay, so my correct answer then, since colony B does go down, is going to be answer choice C, right? It can't be 1 only because I know that 2 does go down, and I know 3 does not. So my answer there is going to be C for 13. All right, next thing I've got is question 14. Of the following, which is closest to the ratio of the total number of insects in all 3 colonies in week 8 to the total number of insects at the initial time of treatment? Okay, so I'm going to have my week 8 is going to be my left number, okay, is my average of how many, or my total number of insects in week 8. And then on the right side of this, or my 2, the right side of my 2 is going to have to be those at the initial time of treatment. So week 8 versus initial. Okay, keep in mind this is the total of all 3 colonies. All right, so if I take a look at my total on week 8, I see I got right around 20 right here, I've got right around 10 right here, and I've got right around 50 right here. So I got 10, 20, and 50. That's going to give me a total of right around 80. Next thing I'm going to look at is at week 0. I've got right around 80, and then I've got right around 65, and right around, we'll say that that's 55. So 65 and 55, they'll total give me 120. 120 plus 80 will give me right around 200. I see I can simplify that 80 to 200. That 80 to 200, that's going to be right around 20. If I divide each one by 20, that's going to be right around 20 to 10, or hang on a minute, I definitely missed that. That's going to be right around 20 to 50. Okay, dividing each side by 4, we're going to get right around 20 to 50. So correct answer there, we can simplify that further, we're going to have that right around 2 to 5. So answer there is going to be A. All right, so that one also not too difficult, just summing up on the graphs, and you're going to get 2 to 5 as that ratio. Answer choice is going to be A there. All right, next thing we're looking at is question 15. We have a right circular cone, has a volume of 24 pi cubic inches. If the height of the cone is 2 inches, what is the radius in inches of the base of the cone? So one SAT math tip and trick that I have is just, it's pretty simple. Just memorize the equations that they give you on the reference sheet. Because if you memorize the equations that they give you on the reference sheet, you don't have to go back and forth between it, and it's going to save you a lot of time. So the volume of a right circular cone, what you should know is that that's 1/3 times pi times the radius squared times your height. So in this case, we know that that's equal to 24 pi, okay, because it tells us that that is the volume. Now we're told the height is 2 inches, so we can go ahead and replace that height with 2. Now we're asked for the radius, so we just solve for the radius here. First thing we're going to do is we're going to have to multiply each side by 3 to get rid of this 1/3. So we multiply each side by 3 to get rid of this 1/3. So we got 24 pi times 3. We'll divide each side by pi, get rid of this pi. Okay, divide each side by pi, get rid of the pi. Next thing we'll divide each side by 2, get rid of this 2. Okay, 24 over 2 is going to be 12. 12 times 3 is going to give me 36 equals r squared. So we got r squared now equals 36. We take the square root of each side to get r, since we need to solve for our radius, and that's going to give us 6 as our radius. So correct answer there is going to be B. So once again, that one is not too difficult. Big thing here is understanding that if you memorize those equations from the reference sheet, it's going to save you a lot of time on the SAT math section. All right, moving on, we got question 16. So we have in 2015, the populations of city X and city Y were equal. From 2010 to 2015, the population of city X increased by 20% and the population of city Y decreased by 10%. The population of city X was 120,000 in 2010. What was the population of city Y in 2010? Okay, we know in 2015 is when X equals Y. Okay, that's in 2015. Now, next thing that we know, population of city X increases by 20% over those 5 years from 2010 to 2015. Now, we know the population was 120,000 in 2010. So it was 120,000 in 2010. We know we're increasing by 20% over the next 5 years to the 2015. Thus, X in 2015 is going to equal 1.2 times 120,000. So I'll plug that in my calculator right now. And that's going to give me 144,000. 144,000 is X. So we know that X is equal to Y in 2015. Now I'm asked for the population in 2010 of city Y. Now I know city Y decreases by 10% from 2010 to 2015. So if its 2015 value is going to be 144,000, since we know that X is equal to Y, then to solve for this 2010 value, we need to take this 144,000 and we need to divide it by 0.9. Now why 0.9? Because we have to divide it by 1 minus that 0.1 that we're decreasing, right? Minus that 0.1 or that 10% that we dropped over that period. So when we do that, we plug that in our calculator, divide by 0.9, and we're going to get 160,000 as our answer. Okay, so our answer there is going to be C. So that one right there, not too bad. Key thing there is understanding that you got to pay attention to your years. If you're not paying attention to your years here, you're going to make a simple mistake and you're going to get this one wrong. So key part here is understanding we got to pay attention to which years we're dealing with, also understanding our rates of increase and decrease of those 10 and 20% respectively. Understand that and you're going to get this one right. So paying attention to details is the crucial part with number 16. Number 17, volume of a sphere. We're given the formula here. R is radius. Which of the following gives a radius in terms of the volumes of the sphere? Okay, all we're doing here is we're solving for our radius, right? What would our radius equal? So what we're going to do is I'm just going to zoom in and I'm just going to, or I'll rewrite it so I don't have to zoom in. So we got our volume, we'll call it V. It's going to equal 4/3 pi r cubed. Okay, we just got to rearrange and solve for r here. So what we're going to do is we're going to multiply by our reciprocal. So we got 4/3, we're going to multiply by 3/4 to get rid of it. So we multiply each side by 3/4. Okay, so now we got a 4 in our denominator. Next thing, we got to divide each side by pi. Get rid of that, put a pi down here. Next thing we got to do is we got to take the cubed root of each side. Okay, so we can get rid of this cube with r by taking the cube root of it. And we got to take the cubed root then of 3v times, or all over 4 pi. Okay, so I see a and b don't have a cubed root, so I can get rid of them. Next thing I look at, I see that I've got 4 pi on top in C, and 4 pi's got to be on the bottom, thus D will be my correct answer. All right, so that one right there, that's question 17. Answer there is going to be D. Key parts there, understanding how to manipulate variables in order to get to that correct answer. If you understand that, then you're going to be perfectly fine with questions that are similar to question 17 on the SAT. All right, we're going to do questions 18, 19, and 20, and then we will go into a couple math tips. We got question 18. We have survey results. We've got an answer. We've got percentages. We're told that the table above shows results of a survey in which tablet users were asked how often they would watch video advertisements in order to access streaming content for free based on the table, which was found closest to the probability that a tablet user answered always, given that the tablet answer did not answer never. All right, we know they didn't answer never, so we're going to get rid of that. Now, what's the probability that they answered always? Well, we have 30.9 as our probability that they answered always out of the total chance between these three, since we know that they didn't answer never. So we're going to have to add then 24.3% plus 13.5% and then plus 30.9%. Okay, so you got a couple options on the way you can put this in your calculator, but essentially you're just going to have these percents written in as some way, right? You can either just write it as 30.9 over 24.3 plus 13.5 plus 30.9, or you can actually convert it to decimals. It's up to you completely. But when you plug that in your calculator, then let's go ahead and figure out what you're going to get. You're going to get right around 0.45, I do believe. I'll plug it in my calculator real quick. Plug it in, and we're going to get, yep, right around 0.45. So correct answer for this one is going to be C for number 18. Yep, so this one right here, not too difficult in my opinion, fairly simple. Key thing here is understanding you have to get rid of never, right? If you don't get rid of never, I'm guessing they have, or actually they don't have 30.9 as a, or they do, they have 0.31. Yep. So key thing there is recognizing you have to get rid of never in your denominator, right? Thus changing your probability. A lot of people probably picked 0.31, right? Because that's about 30.9% as a probability. So that was the key thing there, is understanding you had to get rid of never in your denominator. So correct answer there is C. All right, question 19, we only got two more here. So we got in the equation above, A is a constant, the graph of the equation in the XY plane is a parabola. Which of the following is true about the parabola? Okay, so key thing I'm looking at here, I see my A value is the same in all of them, so I'm not going to go through and look for that Y coordinate. I see I have minimums versus maximums. Now in this case, I see that my graph is going to open down since I've got that negative in front of it. Okay, because this is obviously going to get me a negative x squared. So thus it's going to open down, thus it means I'm going to have a maximum. So I can go ahead and get rid of A and B. Now in between C and D, I see the only difference there is that -3 versus that 3 at my x coordinate. I see that this is in vertex form. In vertex form, I have x minus my x coordinate of my vertex. Right, so in this case, since I have x minus 3, 3 must be my x coordinate of my vertex. Thus my correct answer must be D for number 19. That one right there, key parts to answering that one correct is understanding vertex form, as well as understanding maximums versus minimums and where a parabola's endpoints are going. All right, next thing that we've got is question 20. So this will be our last one for today, and then we'll move into some math tips. So we got the maximum value of a data set consisting of 25 positive integers is 84. So that's our max. A new data set consisting of 26 positive integers, key thing there is that that is one more. It's created by including 96 in the original data set. So now I have a new maximum. Which of the following measures must be 12 greater for the new data set than for the original? Okay, that's not going to be the mean, not going to be the median. It is going to be my range, because my range is my minimum to my maximum. Standard deviation will not change by that much since there are 26 other integers involved. Okay, so hopefully this was helpful. Now let's go and get into some math tips and tricks. Here is an SAT math tip and trick that you can use when you have a number raised to the power of a fraction. So in this case, I'm going to use question 12 from SAT practice test 5 to illustrate as an example. So we have, which of the following is equivalent to 9 raised to the power of 3 over 4? Well, anytime that we have a number raised to the power of a fraction, our denominator of our fraction, or our bottom number, is going to be our root. So in this case, since we have 9 raised to the power of 3/4, we're going to have the fourth root of 9 to the third power. Now, one thing that we can also do, since when we look at our answer choices, we don't have that as an option, right? We see we don't have the fourth root of 9 to the third power as an answer choice. Then what we're going to want to do is take 9, and we know that 9 is equal to 3 squared. So then we're going to put 3 squared in for 9. So we're going to have the fourth root of 3 squared to the third power. 3 squared to the third power. Now, one thing that we know is that with exponents, when we have something like 3 squared raised to the third power, right, and I'll rewrite that. Let's say we have 3 squared raised to the third power. Okay, anytime we have a power raised to a power, we're going to multiply them. Okay, so that's going to equal 3 to the power of 2 times 3, which is going to equal, obviously, 3 to the 6th power. So now we have the fourth root of 3 to the 6th power. Okay, so what we can do now is we can actually rewrite that. We know that the fourth root of 3 to the 6th power is the same as 3 raised to the power of 6 over 4. Okay, so we got 3 raised to the power of 6 over 4. Now, what can we do here? We can simplify that. Okay, obviously 6 over 4 is the same as 3 over 2, so we're going to have 3 to the power of 3 over 2, which obviously when we look at our answer choices, we don't have that because we have to have it in the form with a root. So then when we do that, we have 3 to the power of 3 over 2. We know that that's going to be equal to the 3 to the first power plus, or multiplied by, I'm sorry, not plus, multiplied by 3 to the 1/2 power. Since when we multiply with the same base, we add our exponents, we know that 3 to the power of 3 over 2 is going to equal 3 to the first power times 3 to the 1/2 power. Now, obviously, 3 to the 1/2 power then is going to be the square root of 3. Okay, so we're going to be left with 3 times the square root of 3, which when we look at our answer choices, we see is going to be answer choice D. So D will be our correct answer for this question. So the tips and tricks that you need to keep in mind when dealing with fractions as your exponent is that your denominator is going to be your root, and your numerator is going to be what goes with your base underneath that root. Now, the other thing you're going to want to keep in mind is if you don't see an answer choice after doing that, then take a look at your base number. In this case, the base number was 9, and see if you can turn that into something with an exponent. So in this case, 9 was equal to 3 squared. So then you're going to want to put in 3 squared for 9 and try to solve from there. Right, so those are the big things you want to understand for exponents. Here's an SAT math tip and trick that deals with canceling units to make sure you're getting to your correct answer. I talked about this briefly in a tip and trick video previously, but I want to dedicate a full tip video to it because I think it's that important. So to start, let's take a look at question number 3 from SAT practice test 5. So it states that to make a bakery signature chocolate muffins, a baker needs 2.5 ounces of chocolate for each muffin. How many pounds, now keep in mind, we talked 2.5 ounces above, now we're talking about pounds, always pay attention to changes in units, of chocolate are needed to make 48 signature chocolate muffins. Okay, so we have to make 48 chocolate muffins. I'll use M for muffins. Now, I need to get the number of ounces of chocolate I need in order to get the number of pounds of chocolate I need. So I'm going to multiply by the fact that I need 2.5 ounces per muffin. Okay, so I'll use OU to represent ounces, and that's per one muffin. So that's going to give me my number of ounces of chocolate that I'm going to need. So as we can see, we're going to have to cancel our units of muffins to end with our units in ounces. So that's how we're using canceling units to make sure we're doing this problem correctly. When we plug in 48 times 2.5 in our calculator, because this is on the with calculator section, we're going to end up with 120 ounces. So 120 OU for ounces. Now we take that 120 ounces because we have to answer in pounds, okay? D is incorrect because we have to answer in pounds. So we have 120 ounces. Now we're told that 1 pound is equal to 16 ounces. So then we're going to multiply with our ounces on bottom to cancel our ounces. So we know that 16 must go on the bottom, and we must have 1 pound or 1 lb on top. When we do that, our ounces are going to cancel, and we're going to have 120 over 16, which will leave us with 7.5 pounds as our answer. Okay, so that is how you can use canceling units in order to make sure you're getting to your correct answer. So our answer there is going to be A. Now I'm going to give you another example of this with question 9 from the same SAT practice test 5. So let's go down, let's find question 9. All right, it's right here. Let me erase it real quick so that you can see what I'm going to do here. All right, so let's go ahead and take a look at our question here. So it deals with Olympic Games and converting between kilometers and miles. So we have in the 1908 Olympic Games, the Olympic marathon was lengthened from 40 kilometers to approximately 42 kilometers. Of the following, which is closest to the increase in the distance, so I'm looking at a change in distance, a positive change, of the Olympic marathon in miles. So we know that we increased from 40 kilometers to 42. That's a change of 2 kilometers because 42 minus 40 is 2. So we have a change of 2 kilometers. We're asked for what that change is in miles. So we know that 1 mile is approximately 16 kilometers. Therefore, 1 mile is approximately 1.6 kilometers. So once again, we need kilometers on bottom to cancel our units. So we'll put 1m for mile on top. We got to divide by 1.6 kilometers to cancel kilometers and end with our units in miles. So we see we're going to have 2 over 1.6. I'll plug that into my calculator. And I see that I'm going to get 1.25 miles. So my correct answer will be 1.25, which will be answer choice B. So hopefully you can see how canceling units is going to help you make sure that you're doing the correct ratio and getting to that correct answer. So hopefully this video has helped. Today I have an SAT math tip and trick that I want to share with you that deals with similar triangles. So to illustrate the similar triangles and how we can use them to save time and find the correct answer efficiently on the SAT math section, I'm going to use question 18 from SAT practice test 6. So it says in the figure above, line BD is parallel to line AE. What is the length of C to E? So we're going to look for this length right here from C to E. So the thing I see immediately is that we have similar triangles. How do I know that I have similar triangles? Well, I see I have a shared angle right there at CEA, right? This angle E right there, I'll put it in blue. And then I also see I have a shared angle at DC to B, right, at this angle C. So I see I have those shared angles, also have this shared right angle here, so I know I got similar triangles from that, right? So now at this point what I can do is, since I know I have similar triangles, I see that my hypotenuse CD, right, I've got this hypotenuse here, I'll put it in green so you can see it better. Okay, this hypotenuse right here, if I solve for that, I can actually solve for CE, right? And I have to solve for this hypotenuse CD before I can solve for CE, because I see my corresponding sides. In this case, I'll put it in, I'll just go ahead and highlight it. Okay, this side here from D to B, that corresponds to the side E to A and this larger triangle. And I see that the ratios there is obviously multiplied by 3, because 6 times 3 gives me 18. So I know that if I find my hypotenuse CD, then I can multiply that by 3 to get my answer for CE. So I see immediately what jumps out to me is I have a 6 here and an 8 here. I know 8 squared is going to give me 64, and I know 6 squared is going to give me 36. I know that's going to equal 100, and I know the square root of 100 is going to give me 10. So I know my hypotenuse will indeed be 10 then, right? For CD, that's not my answer though, because I'm asked for C to E. So I take that 10 then, multiply it by 3, since that is my ratio of my larger triangle to my smaller triangle, and I get 10 times 3 is 30. So my answer there would be 30 for the length of CE. So the big things to understand here is with similar triangles, you want to find that ratio of your larger triangle to your smaller triangle, or your smaller triangle to your larger triangle. Find that ratio. In this case, multiplying your smaller triangle by 3 gives you your larger triangle for your corresponding sides. Next thing you want to do is determine what you're trying to find, right? CE in this case, that's the larger triangle's hypotenuse. Now in order to do that, you need to know your smaller triangle's hypotenuse. At that point, I applied a squared plus b squared equals c squared in order to solve for that hypotenuse. When I did that, I found my hypotenuse of 10, multiplied by 3, got 30 for the length of CE. So that's how you want to approach these similar triangles problems, is you want to identify what you want to solve, you want to find if it's in your smaller triangle or your larger one, then use the corresponding sides to find what ratio there are between the sides, and then obviously you go ahead and solve from there. So hopefully this video is helpful. Today I have an SAT math tip and trick for you that deals with interpreting two-way tables. So if you don't know what a two-way table is, that's this right here, right? You have a table and you have categories on this side as well as up top. So you have columns and rows of categories, and you have to be able to interpret it based on totals in the row, totals in the columns, and totals overall. So let's take a look at question 1 from SAT Practice Test 7 to illustrate my tips and tricks with two-way tables. So a lot of it is just dealing with marking up the two-way table to make sure you're not making a mistake as far as doing rows when you should be doing columns, or not doing the total. So let's go ahead and take a look at this question. So we have the table above shows the kinds of foods that are fed to cats and dogs currently boarded at a pet care facility. What fraction of the dogs are fed only dry food? Okay, key thing here that jumps out to me right away. When I'm dealing with two-way tables, I'm generally asked about fractions, right? Fractions or percentages or things like that. Now in this case, it's of the dogs only. Okay, what fraction of the dogs? So I want to know my total number of dogs. I see my total number of dogs is 25, because if I go from this row over, I see my total number of dogs is 25. So that'll be my total. Okay, so what fraction of the dogs are fed only dry food? Well, I see my fed only dry food columns right here. I go down to dogs. I see I have 2 dogs are fed only dry food out of 25 dogs. Therefore, my fraction will be 2 out of 25. Okay, so my correct answer there is going to be B. Now, when you're dealing with a two-way table, I recommend marking up the table, okay? Now, here's why. When you mark up the table, it's harder for you to make a simple mistake, or a dumb mistake, as some people would call it, right? If I didn't mark this, and I was just looking at it, I might only go to 23 and not see my total is 25. So I just recommend boxing things up with two-way tables. I think it makes it easier to prevent those mistakes, make sure that you're getting to the correct answer, not making a dumb mistake that could cost you points, especially because two-way tables, in my opinion, they can be pretty easy points because generally it's just making fractions or dealing with percentages. So I highly recommend marking up two-way tables. Here is an SAT math tip I have for you today. So when you take the SAT math section, be it the with calculator or the without calculator section, you're going to be given a bunch of equations with shapes as references. Now, understanding these equations is crucial to scoring high on the SAT math section. Now, one thing I also recommend doing for the SAT math section is memorizing all of these equations. Now, the reason I recommend memorizing all these equations is so that way you don't have to flip back and forth between your questions and the reference page during the SAT math section. Because if you're flipping back and forth to find these equations and you don't have them memorized, it's going to end up wasting time. Whereas if you have them memorized, you're going to be able to know them right away, implement them on the question, and you're not going to waste time flipping back and forth between pages. Because flipping between pages earns you 0 points on the SAT. So memorizing these equations and understanding how they work is crucial to scoring high on the SAT, in my opinion. Therefore, you want to go into the SAT having these equations memorized. Now, the other thing that you should understand is also these little 3 sentences down here. The number of degrees of an arc in a circle is 360 degrees, number of radians of arc in a circle is 2 pi, and the sum of the measures and degrees of the angles of a triangle is 180. If you can memorize these equations and those 3 sentences right there, it's definitely going to help you improve your speed on the SAT math section for the with calculator and the without calculator. So today's reading practice, I'm going to be going through passage 5 from SAT Practice Test 5. This is a science passage, so I'll be approaching it similar to how I would if I were taking the SAT, but obviously I'll be going slower and providing more tips and tricks and advice for the SAT reading section. So this isn't necessarily a walkthrough, it's more me going through the passage and then providing you with tips, tricks, and advice for the reading section based on different questions and pointing out key things and strategies that I would recommend that you use for the SAT reading section. So with that, let's go ahead and get started with questions 42 to 52. So how I approach the SAT reading passages is I start by simply doing an initial read through of the passages. So I see that this passage is adopted from Joshua 4, and it's titled Moonwalking with Einstein, The Art and Science of Remembering Everything, copyright in 2011. So what I'm going to do is I'm just going to go ahead and do my initial read through. So as I read through, I'm going to underline certain things, and I'll go through why I underline the things at the end, but for now I'm just going to start with my initial read through. So pay attention to what I underline, and then at the end I'll go back and I'll tell you why I underline certain things. So I have, in 2000, a neuroscientist at University College London named Eleanor Maguire wanted to find out what effect, if any, all that driving around the labyrinth streets of London might have on Cabby's brains. When she brought 16 taxi drivers into her lab and examined their brains in an MRI scanner, she found one surprising and important difference. The right posterior hippocampus, a part of the brain known to be involved in spatial navigation, was 7% larger than normal in the Cabbies, a small but very significant difference. Maguire concluded that all the wayfinding around London had physically altered the gross structure of their brains. The more years a Cabby had been on the road, the more pronounced the effect. The brain is a mutable organ, capable within limits of reorganizing itself and readapting to new kinds of sensory input, a phenomenon known as neuroplasticity. It had long been thought that the adult brain was incapable of spawning new neurons, that while learning had caused synapses to rearrange themselves and new links to form between between brain cells to form, the brain's basic anatomical structure was more or less static. McGuire's study suggested the old inherent wisdom was simply not true. After her groundbreaking study of London cabbies, McGuire decided to turn her attention to mental athletes. She teamed up with Elizabeth Valentine and John Wilding, authors of the academic monograph Superior Memory, to study 10 individuals who had finished near the top of the World Memory Championship. They wanted to find out if the memorizers' brains were, like the London cabbies, structurally different from the rest of ours, or if they were somehow just making better use of the memory abilities that we all possess. The researchers put both the mental athletes and a group of matched control subjects into MRI scanners and asked them to memorize 3-digit numbers, black and white photographs of people's faces, and magnified images of snowflakes while their brains were being scanned. McGuire and her team thought it was possible that they might discover anatomical differences in the brains of the memory champs. Evidence that their brains had somehow reorganized themselves in the process of doing all that intensive remembering. But when the researchers reviewed the imaging data, not a single statistical significant structural difference turned up. The brains of the mental athletes appeared to be indistinguishable from those of the control subjects. What's more, on every single test of general cognitive ability, the mental athletes' scores came back well within the normal range. The memory champs weren't smarter and they didn't have special brains, but there was one telling difference between the brains of mental athletes and the control subjects. When the researchers looked at which parts of the brain were lighting up when the mental athletes were memorizing, they found that they were activating entirely different circuitry. According to the functional MRIs, regions of the brain that were less active in the control subjects seemed to be working in overdrive for the mental athletes. Surprisingly, when the mental athletes were learning new information, they were engaging several regions of the brain known to be involved in 2 specific tasks: visual memory and spatial navigation, including the same right posterior hippocampal region that the London cabbies had enlarged with all their daily wayfinding. At first glance, this wouldn't seem to make any sense. Why would mental athletes be conjuring images in their mind's eye when they were trying to learn 3-digit numbers? Why would they be navigating like London cabbies when they're supposed to be remembering the shapes of snowflakes? McGuire and her team asked the mental athletes to describe what exactly was going on in their minds as they memorized. The mental athletes said they were consciously converting the information they were being asked to memorize into images and distributing those images along familiar spatial journeys. They weren't doing this automatically or because it was an inborn talent they'd nurtured since childhood. Rather, the unexpected patterns of neural activity that McGuire's fMRIs turned up were the result of training and practice. Alright, so I'm just going to do a quick overview of why I highlighted it. In this case, I'm highlighting obviously on the SAT. If it's on paper, you'll be underlining things with your pencil. If it's on the computer in the future, I would imagine that they would have a highlight tool for the reading section or an underline tool, or you can just make notes of line numbers quickly on a piece of paper if they allow scrap paper as well. But let's go ahead and cover why I highlighted these things. All right, so first thing that I highlighted, we have she found one surprising difference. Okay, anytime that I see that I have something that says something is surprising or something is an important difference, that's going to pretty much put off a flag right in my mind. Okay, it's saying something's important, it's important change or difference, something is surprising. That's telling me this is probably going to be important. So that's why I highlighted that there. Next thing we have, the right posterior hippocampus, a part of the brain known to be involved in spatial navigation, was 7% larger than in the normal cavity. So that's describing, once again, describing that surprising and important difference. So I want to know what that surprising and important difference was. That's why I highlighted it. Next thing we see is that I highlighted that they had physically altered the growth structure of their brains. Okay, so that's something that's really important because I see in my title that we're talking about the art and science of remembering everything, right? And we have someone who has a 7% larger portion of their brain. Okay, so now I go through, we see that they altered the structure of their brain. We see that it had long been thought that the adult brain was incapable of spawning new neurons. Okay, so that's a claim from the past. Now, because it says that it had long been thought this, that's indicating to me that they're probably going to try to counter or refute that past claim that the brain is incapable of spawning new neurons. So we have that while learning caused synapses to rearrange themselves and new links between brain cells to form, the brain's basic anatomical structure was more or less static. McGuire's study suggests the old inherent wisdom is simply not true. So that right there, I highlighted it because it's telling me a claim from the past or a belief in the past that is now countered by this new evidence that came up. So that's going to be something that's pretty important to the passage. That's why I highlighted that there. Next, as we go down, we see that we have, like the London cabbies, structurally different from the rest of ours, or if they somehow are just making better use of the memory abilities that we all possess. So this right here is giving me my driving question behind my investigation. Anytime that I have a driving question behind my investigation for the science section, and keep in mind this is a science passage, I want to make sure that I highlight that. So in this case, this driving question is, are these great memorizers, do they have different shaped brains than ours, or different form of brain than ours? In the sense that it's shaped differently with certain parts being larger versus smaller, or are they just using it differently? So that was our driving question behind this. So anytime I have a driving question on the SAT science section, I'm going to highlight that. Next, I look over here, we have, but when the researchers reviewed the imaging data, not a single significant structural difference turned up. So that's telling me, in response to that driving question, that it is not because of any sort of difference in the form of the brain, okay? So that right there is telling me it must then, or it is likely, or we'll just read on. So next thing I highlighted, we have the test of general cognitive ability. Mental athlete scores came back well within the range. So it's not just because the normal people versus the professional memorizers have different IQs, right? So that's eliminating a confounding variable. If you don't know what a confounding variable is, a confounding variable just means that it's something that could complicate or make it so you can't draw a conclusion from your independent variable. So next up, we take a look at next thing that we highlighted. We have, but there was one telling difference between the brains of the mental athletes and the control subjects. Okay, this right here I highlighted it because it's telling me that what comes after it. And if you didn't want to highlight this part right here, I would honestly be okay with that because it's not necessarily too important. I just highlighted it because it told me that there's going to be a telling difference between these two brains and their use during this memorization. Okay, next thing I highlight is the difference that I just talked about in this highlighted part above. Okay, what's that difference? They're using different circuitry and then having parts of the brain be less active in controls where they're working in overdrive for mental athletes. So that's showing that difference. Next thing, we talk about how the difference, right, the part that's working in overdrive is that visual memory and spatial navigation. So once again, that's critical to understanding this passage and understanding this study. We have London cabbies had enlarged. It's the same region that the London cabbies had enlarged in all their way day finding. Okay, I highlighted that because it connects it back to our intro, right, where we talk about these London cabbies. So since we hadn't talked about them for a while, I'm wanting to connect that back in order to give that purpose of why we did include it there. All right, so reading on, we got two more things I highlighted. We have they were being asked to memorize into images. Okay, so the professional memorizers are converting this information into images, and this unexpected patterns of neural activity from the fMRIs, they were the result of training and practice. So these professional memorizers have practiced turning them into images. Okay, so the big things you're going to want to highlight and underline when you do your initial read through on the SAT reading section, if you haven't picked up on it already. If it's a science passage, you want to pay attention to what your driving question behind your investigation is. Always pay attention to that, highlight that on the science sections. Additionally, on the science sections, one thing I don't recommend highlighting or underlining all the time is evidence. If you're highlighting and underlining evidence all the time, it's just going to end up where you're highlighting pretty much your whole essay, so I would recommend avoiding that. What I would recommend highlighting, though, is anything like a claim, okay, or anything that says something is a difference, or something is important, or something is surprising. Anything that you see, anywhere you see words like that, I'd recommend highlighting or underlining that. Anything that answers your driving question, okay, so anything that answers your driving question or eliminates one thing from answering your driving question, you're going to want to highlight that as well. All right, so now let's go ahead and get into some of the questions and my tips for the questions. Now keep in mind that you don't want to take too much time annotating that passage, right? And I'll talk about that in a pacing video later on. I also talked about that in my video, I believe, on day 2. It looks like we just moved too far ahead. All right, so we got question 42. Let's get started. So we have, according to the passage, McGuire's findings regarding taxi drivers are significant because they do what? All right, so if we think about why the information in taxi drivers is contained in the beginning, why is it significant? Well, if we actually take a look back, we actually highlighted why it's significant. Because it had previously been thought that the brain was not capable of spawning new neurons. And I'm going to put this in blue so you see where I'm talking about. We have the adult brain being incapable of spawning new neurons, that while learning caused synapses to rearrange themselves and new links between brain cells to form, the brain's basic anatomical structure was more or less static. Okay, so previously it had been thought that the brain was not capable of spawning new neurons or changing. However, this study, the reason it's important is it suggests that that is not true. It suggests that the brain is capable of changing form. So that's the reason why this is important, or why it's significant. So let's go ahead and find an answer that says that. We have option A, demonstrate the validity of a new method. There is no new method, so that's going to be incorrect. Option B, provide evidence for a popular viewpoint. We're not providing evidence for a popular viewpoint. B is incorrect. C, call into question an earlier consensus. Yes, it was previously believed that the brain couldn't spawn new neurons. However, after this investigation, we believe that it is possible because these London cabbie drivers have 7% larger brains in a certain section. Option D, challenge the authenticity of previous data. We're not challenging the authenticity of previous data, so D is incorrect as well. Okay, now I have a tip here for number 43. When you're dealing with a question that just asks you to provide evidence to the previous question or provide evidence to some statement above it, what you're going to want to do, in my opinion, if you don't already know where it is, so in this case, let's say that you just remember, oh, I just provided evidence for C because when I looked back, I saw at lines 20 to 26, that was where my evidence was, because it talks about how previously they thought it was true, but now they realize that it's not true. Okay, so obviously if you remember where it was and you have it highlighted, that's going to be really easy to find your evidence. That's why I recommend underlining as you go through and read on your initial read through. So obviously that would make it really easy if you already remember, but let's just say, for example, that you don't remember where it was. Let's say that you don't know if it was in lines 8, lines 12, 17, or 20. You're just really not sure. One thing I would recommend doing is looking at these keywords, and I call these keywords, they're going to be these things that are before and after the dots. Okay, so I'll underline them in blue. Those are your keywords. So what I recommend doing then is thinking about what you have to provide support for. In this case, you have to provide support for that a previous belief held in science is being called into question, right? We're calling into question a previous belief and saying that it's no longer true. So the key things I'd be looking at would be the words like false, words like true, words like in the past or previously, okay? Because those would all be indicators or keywords that would suggest a change from the past, a belief in the past that is no longer held or that is being challenged. So I'd look for words like that as my keywords. So in this case, if I look at them, I have the word true right here in these lines 20 to 26, which I already know is my answer, right? Because we already discussed it being the evidence when we discussed question 42. So you see that if you were to start then at true, right? Because let's just say you didn't remember it was lines 20 to 26, then you would start by looking at lines 20 to 26. You'd read it, you'd see, oh, obviously that's supporting my answer, and you'd be able to pick D without having to go through and read C, B, and A. So that's going to save you time. Now, you can't always just pick the word that, or the answer choice that has your keyword, because you always have to go back and read it just to make sure that it is indeed the correct sentence to support your previous answer. So the keyword method is a good method because it helps you save time, but you do always want to go back and read through that sentence just to make sure that it is indeed correct. So answer there is going to be D. Now we can go and move on to 44. As used in line 24, basic most nearly means what? Well, let's go take a look. So with these most nearly means questions, I have a tip on this one that you'll see after I do this walkthrough that really talks more in depth about them. But what I always recommend doing is going back to the passage first, finding the word. In this case, I'm going to erase a little bit of this highlight just so you can see the word basic and what I'm going to do here. So I'll put it in red just so you can see it. Okay, so we found our word basic in line 24. So what I recommend doing with these most nearly means questions is going back to the text, beginning at where the sentence starts, and then that way you get that context, and then coming up with your own answer for what it most nearly means, and then finding the choice that either matches what you came up with or is closest in meaning to it. So let's go ahead and go through this. We have, it had long been thought that the adult brain was incapable of spawning new neurons, that while learning caused new synapses to rearrange themselves and new links between the brain cells to form, the brain's basic anatomical structure was more or less static. In this case, when we say the brain's basic anatomical structure, we're really talking about the brain's structure from birth, okay? So the brain's fundamental structure. Fundamental here could replace the word basic. That would be one word I'd be looking at. So in this case, you see that I'm coming up with my own word first before I go down and look at my answer choices. The reason that this is beneficial is because it helps you to not get swayed by the answer choices. Another common error people make on this type of question is that they'll look at the answer choices and just pick whatever answer choice is a synonym or that they think means the same thing as the word out of context. But the key part here is that you have to read the word in context in order to understand what it means. In this case, fundamental is the answer that we came up with by going back to the text, and that's actually on here. Okay, so we know that that'll be our answer. Now let's say that we came up with an answer choice other than fundamental. Let's say that we went up to the text and we came up with, let's see what another word that we could possibly have come up with here. The brain's basic anatomical structure, its function, or its fundamental anatomical structure. Another word that we probably could have used, maybe there's really not anything you could really use other than fundamental in this case. I give a tip video that you'll see in this day 4 video that talks about a couple other examples of this, so you'll see it more there. But let's just say we came up with a different word other than fundamental, right? But either way, we have to get that meaning of it being the structure from birth, that initial structure from birth, right? That structure that is given to every human being, obviously, the structure of the brain. So the only one that really encapsulates that answer here is D. You'll see in this video later on when I go through that tip for the most nearly means questions that what I talk about is if you come up with an answer choice that isn't on here, right, you don't have an answer choice on here as your word, what you're going to do is you want to look for an answer choice that means similar to the word that you came up with, and that'll usually be your answer. But yeah, watch out for if you're just selecting synonyms, you're probably going to get it wrong. You want to make sure that you really look at what the word means in context. That's the most important part, is make sure you look at what the word means in context. So answer there is going to be fundamental. All right, let's take a look at 45. We have, which question was McGuire's study of mental athletes primarily intended to answer? Well, a study of mental athletes, the goal behind it was to determine if it's their brain structure or their use of brain, that the way they use their brain, that actually allows them to have this great memorization abilities. So let's go ahead and take a look at an answer choice, find the one that says that. We have option A, does the act of memorization make use of different brain structures than does the act of navigation? No, that's not our primary goal behind this study. Option B, do mental athletes inherit their unusual brain structure, or do the structures develop as a result of specific activities? That's not addressing the fact that we're looking at what parts of the brain that they are using. Option C, does heightened memorization ability reflect abnormal brain structure or an unusual use of normal brain structure? Yes, that's the question that we're trying to answer. And obviously, once you find your correct answer in your going through the SAT reading section, you don't have to read the other answers if you're confident that your answer is correct. So if you found C and you're confident it's correct, you wouldn't have to read through D. In this case, I'll read through D just to show you why it's wrong. D says, what is the relationship between general cognitive ability and the unusual brain structures of mental athletes? The key thing here is that the brain structures of mental athletes aren't actually unusual. It's just the way they're using their brains that is unusual. Next question, we see it's going to be evidence. So once again, let's use that keyword strategy for the evidence, and let's see if we can get that answer. Obviously, if you know where the lines are that support this, does heightened memorization ability reflect abnormal brain structure or an unusual use of normal brain structure, you just go ahead and circle your answer with the lines. But let's say that you don't know which lines contain it. Let's use that keyword strategy here. All right, so the key thing that I'm seeing here for question 45 is going to be the fact that we're talking about an abnormal brain structure in one versus an unusual use of brain structure. So I would look for something that's talking about the brain having possessing or having some strange or varying weight or largeness or size, or something in how they're using the brain. Okay, so my keywords here, they could be something like the way that the brain is structured. So I would look for something like structure as a keyword. I would look for something like structure, function. I would look for something like, really those two would be what I'm looking at. Now in this case, if I look at my options, I have after and athlete, so I'm not going to start there. Okay, I'm not going to start there. If I look at the next one, I have they and possess. Possess is good because we could be talking about possessing some abnormal trait in the brain. So I would say that that is a possibility for where I should start. I look at researchers and scanned. Scanned isn't horrible, but I think possess is better just because we're talking about abnormal brain structure, and I think that it's quite more likely that we would be talking about possessing some abnormal brain structure. So scanned would be the second spot that I'd go. This would be the first, and then I see 52 to 54. What's range? I'd say that that's my fourth spot. So this is the order that I would go through and check the evidence. So if I go to lines 33 and 37, right, I see that I've got 33 to 37. We have, they wanted to find out if the memorizers' brains were like the London cabbies, structurally different from the rest of ours, or if they somehow were just making better use of the memory abilities that we all possess. So in this case, if I look at that, the big thing that I take away is that it's answering that driving question, right? And you see that we annotated that as well, that's answering our driving question. We see that our previous question that we need to provide evidence for is really asking about the driving question behind this passage. So our correct answer there will indeed be B for 46. So in that case, since we found our correct answer, we don't have to go and read through A, C, and D. Now, one thing that you're probably thinking is, if we annotated it, we probably knew where it was, and obviously you're correct. I just wanted to illustrate an example in which if you didn't know which lines it was in, let's say that you didn't have in your annotations, this would how you'd be wanting to approach it, by using that keyword strategy. In order to, so that way you don't have to read through all four. You can probably find it earlier on by doing that. All right, now we got 47. As used in line 39, matched most nearly means what? So we're going to go to line 39, take a look at matched. If we take a look at line 39, we have the researchers put both the mental athletes and a group of matched control subjects into MRI scanners and asked them to memorize 3-digit numbers. Okay, what matched control subjects are, the key part here is that you pretty much need to know what control subjects are in order to get what matched means. Okay, now control subjects, they're going to be subjects that are really similar or very comparable to the other group in your experiment. So in this case, that's the mental athletes. So they're taking the mental athletes and they're taking people who are very, very similar to them. That way they can control for variables that might cause differences other than how they're using their brains or their difference in brain structure. Okay, so in this case, matched is going to be most nearly meaning to comparable. Now, if we take a look at our options, we see identical as an option. The problem with that is you're never going to have two people who are identical. Okay, so that's going to be wrong. So correct answer there is going to be comparable, not going to be distinguishable, not going to be competing. Let's take a look at 48. The main purpose of the fifth paragraph in lines 57 to 65 is to do what? Well, let's go take a look at that fifth paragraph. So lines 57 to 65. Anytime we're directed to lines, we want to use that to our advantage. So we see that we're talking about that one telling difference between the brains of the mental athletes and the control subjects. I'll put it in red so you can see where I'm pointing to. We see that they found that they were activating different circuitry. We talk about the parts of the brain that are being activated, or not the parts of the brain, but how much they're being activated, right? We talk about overdrive of one part of the brain for these mental athletes. So that's going to be our main focus there, is that difference in how they're using their brains. So find an answer choice that says that for 48. We see that that's going to be answer choice C, identifying an important finding in the study of the mental athletes. That important finding being the fact that they use different parts of their brain. Okay, if we look at options A, B, and D, let's discuss why they are wrong real quick. So we have relate McGuire's study of mental athletes to her study of taxi drivers. We do not do that there. B, speculate on the reason for the unexpected results. We don't speculate on that reason. We just introduce those unexpected results. D, transitioning from a summary of findings to a description of her methods. We're not describing her methods. So correct answer there is going to be C. Now let's take a look at question 49. According to the passage, when compared to mental athletes, the individuals in the control group in McGuire's second study do what? Well, we know that those individuals in the control group in the second study, compared to the non-control group, we know that they are exhibiting different patterns of brain activity. Okay, so our answer there is going to be C. And why do we know that? Well, in our paragraph, or I'll go ahead and show you where it is, we know that we talk about, and we were just there, we talk about how we have a working in overdrive of the mental athletes in that portion of the brain that deals with images, versus in the control or the comparable group, they were less active. Okay, so that's a difference in activity of the brain. We have it working in overdrive in the mental athletes. So answer there is going to be C. Let's go ahead and just talk about why A, B, and D are wrong real quick as well. We have option A, showed less brain activity overall. It doesn't say that they showed less brain activity overall, just different patterns of the brain activity, right? We talk about one region working in overdrive for one that is not working in overdrive for the other. Option B, demonstrating a wider range of cognitive ability. Once again, we said that they had approximately the same IQs or approximately the same intelligence. Option D, displaying noticeably smaller hippocampal regions. Their hippocampal regions were the same. Okay, so that would be wrong as well. So answer there is going to be C. Now we got 50. The passage most strongly suggests that mental athletes are successful at memorization because they do what? Well, that's going to be using the part of the brain that converts things into images. So if we take a look at what our answer choices are, we'll just start with A. We have exploit parts of the brain normally not used in routine memorization. Yes, they're using that part of the brain that uses images, right, that the London cabbie drivers use, rather than just the sort of language parts of the brain. So we have option B, convert information into memorize. They are trying to memorize into abstract symbols. No, the symbols aren't abstract, they are images. C, organizing information into numerical lists. No, they're images. And then D, exercising brains regularly through puzzles and other mental challenges. That's not the big difference here. The big difference is they're using the part of the brain that most people don't, and that's the part of the brain that is involved in images. 51, best evidence. Okay, best evidence here. This one, let's go ahead and try to use, once again, the keyword method. So obviously, if you knew where your evidence was at, then obviously that'd make it easier. Let's say that you're not sure which lines it's in. Let's go ahead and try using the keyword method. So if we know what we have to provide our evidence for, that's for parts of the brain not normally used in routine memorization. So I'm going to look for a surprising result because we know that this indeed was surprising. So the word surprisingly right here immediately jumps out to me. If I look at my other options, we have at first, that's not really helping me. McGuire, not helping me. And they, also not helping me. Childhood, also not helping me. Memorized, that'd be my second choice. Surprisingly is much more likely to have my evidence there. Sense, also not helping me. Wayfinding, that's also probably going to help me because we want to show that they're using that same region of the brain as those London cabbie drivers who were wayfinding around the city. So obviously my first choice here, I'm going to start with A. Okay, so I'm going to look at lines 66 to 72, see if it supports my answer. All right, 66 to 72. Surprisingly, when the mental athletes were learning new information, they were engaging several regions of the brain known to be involved in two specific tasks: visual memory and spatial navigation, including the same right posterior hippocampal region that the London cabbies had enlarged with all their daily wayfinding. All right, what that's showing is that they're using that image part of the brain, thus supporting our answer in 50 by saying they're exploiting parts of the brain not normally used in routine memorization. So my correct answer there for 51 will indeed be A. Okay, so we can go ahead and get rid of B, C, and D there. All right, let's take a look at 52. The questions in lines 74 to 48 primarily serve to do what? Well, let's go take a look. Anytime that we are directed to questions, we want to go, or two lines in the passage, we want to go there. We don't want to just guess blind. So we take a look at 74 to 78. I'll highlight this, or I'll put it in blue. We have, why would mental athletes be conjuring images in their mind's eye when they are trying to learn 3-digit numbers? Why should they be navigating like London cabbies when they're supposed to be remembering the shapes of snowflakes? So these are all showing these questions that arose as a result of this study. Okay, so these surprising and intriguing questions that arose as a result of the study. So we look for an answer choice that has that. We have option A, raise doubts about the reliability of the conclusions reached by McGuire. No, we're not raising doubts about reliability of conclusions. B, emphasizing and elaborating on initially puzzling results of their study of mental athletes. Yes. Okay, initially we were questioning why they are using these parts of the brain that the London cabbies are using. So that would be our correct answer there, is B for 52. Now, if we look at C and D, we can go ahead and explain why those are wrong as well. C says imply that McGuire's findings undermine earlier studies of the same phenomenon. Now, in this case, we got implying McGuire's findings undermine earlier studies. We're not undermining any earlier studies, so that's incorrect. D, introducing and explaining connection between McGuire's 2 studies and her earlier work. We're also not explaining or introducing and explaining a connection there. All we're doing really is questioning things. There's no explanation between that connection. We are questioning at that point in time. So our answer there would be B. So obviously I went really slow on this one because I just wanted to give you tips and tricks and advice for answering these types of questions. So I will do a walkthrough where I do go at the pace that I normally go in the SAT reading section at some point in this 14 days. For today, since it was the first day that we were tackling a reading passage, I wanted to go slower and break things down more. At the end of this video, I'm going to start playing a few reading tips. Today's video is probably going to be longer than an hour because of that, but that's okay. I want you to see these reading tips because I think they're really important to know. Some of them you've already kind of gotten a hint at as I went through this passage because I use them obviously, but I think that it'll help you to see other examples as well. So hopefully this was helpful, and now let's go and get into those reading tips. Today I have an SAT reading tip for you that deals with words in context questions. So words in context questions are pretty easy to tell because they end in most nearly means. So what they're going to do is they're going to direct you to some line in the passage, in this case line 14. They're going to ask you about a word and ask you what it most nearly means. Now, when approaching these questions, the strategy that I recommend using and that I use to score 1590 on the SAT is when you have a most nearly means question, don't look at your answer choices until after you've gone back to the line that it directs you to, read the sentence, and come up with your own answer first. By coming up with your own answer first, it's going to help you not be swayed or get stuck between two answer choices and not know which one to pick. So in this case, let's go ahead and take a look at how I would approach this. So I'd read it, I'd say, as used in line 14, simple most nearly means. I'd go to line 14 and find the word simple, and I'd come up with what I think it would mean in that context. So let's go back to line 14 and let's find simple. We see that we have line 14 on the right side of my screen. We have, but change the conversation to food and suddenly efficiency doesn't look so good. Conventional industrial agriculture has become incredibly efficient on a simple land to food basis. So in this case, it's talking about a simple land to food basis. Another word that we could use there would be straightforward, right? We want to talk about it being a land to food basis only, right? So on a straightforward land to food basis, we wouldn't want to use any other word than straightforward. Really, there's nothing else that would mean that it's only on that land to food basis or that food to land basis. So let's go down, take a look at our question. We see we do have straightforward as an answer choice, so thus that would be our answer. Now let's say that we didn't come up with straightforward. Let's say we came up with a, let's say that we thought pure was going to be our correct answer on a pure land to food basis, right? We obviously would then go through and we look at our options and find which was closest to pure. Now in this case, the closest to pure would also be straightforward, so then we would get to straightforward as well, right? We look at option B, it says modest. We're not talking about a modest land to food basis. We're talking about a straightforward, a simple, or a pure land to food basis. We wouldn't say unadorned and we wouldn't say easy either. We want to be talking about something that is a pure land to food basis, nothing else but that. So straightforward or pure. So obviously you want to come up with straightforward. If you got it right away, that's perfect. If you came up with pure, then you would be looking for something that, or a word that means the same as pure, which in this case straightforward does as well. So next, let's go ahead and do another example of this one. So let's go down and let's find question 29. So question 29 is another words in context question. It says in line 88, sheer most nearly means what? So obviously the words most nearly means tell us it's going to be a words in context question. We're directed to line 88, and we are asked for for sheer. So let's go ahead and take a look. So let's go to line 88, find sheer. got line 88. All right, so I'll highlight it so you can see it. So we've got, but for delivering sheer calories, especially in our stable crops of wheat, rice, maize, soybeans, and so on, conventional farms have the advantage right now. Okay, so in this context, we're talking about sheer calories. And if you wanted to get a little bit more context, it's always okay to read a little bit more behind, so you could read that part as well that I'm highlighting right now. But in this case, we're talking about sheer calories, but for sheer calories or pure calories or calories only. So the most nearly means I'd be looking for here would be pure calories or solely calories for delivering solely calories, but solely wouldn't work here because when we're using the word sheer, we also want to make sure that it's the same type of word as pure, right? We're describing the calories, thus it's an adjective, so we want to use an adjective there as well if possible. So in this case, we'd be looking for the word pure if that is an option. Let's take a look. Okay, we're talking about pure calories or sheer calories. We want nothing but the calories and we want them in a bulk amount. So we see we do have pure, so pure would be our correct answer there. Let's go ahead and run through. Let's say that we didn't come up with pure. Let's say we came up with solely, right? We wanted to describe it as being only calories. Well, let's go ahead and look at why A through C would be wrong then. So if we didn't come up with pure, let's say we came up with a different word such as solely calories, or only calories, we can go ahead and use process of elimination, get rid of A through C. So I'll go ahead and take you through that. So option A, transparent. We wouldn't describe them as transparent calories because transparent essentially means see-through, and that's not a good way to describe the calories. Abrupt calories, we wouldn't describe calories as abrupt. Steep, we would not describe calories as steep either. We want something that's showing that they are sheer calories or only calories. That's all we're looking at. They are pure calories. There's only calories that we are considering. Okay, so then by process of elimination, even if we didn't come up with pure right away and we came up with solely or only calories, we obviously can get rid of A through C because they would not work, and C, D would be our correct answer because it's the only choice that shows that we are only talking about calories, the pure calories, meaning most nearly to sheer. All right, so I got one more example of this for you. This is going to be with question 37. So let's go find question 37. Okay, we've got as used in line 85, boost most nearly means what? So let's go ahead and go up to line 85. We'll find boost and we'll come up with what it most nearly means before reading our answer choices. So we have, will companies be able to boost their products by manipulating online ratings on a massive scale? Okay, so this passage, you would obviously have context going into it because you would have read it. This passage is talking about online reviews and how they can be swayed by user choice and how companies could potentially use that to boost their products. Now, boost in this case would most nearly mean market or promote. Okay, they want to use those to market or promote their products. So I'd be looking for either of those. Promote would be a better choice in my opinion because it's really relating more to boost. Market is a little bit of a worse choice than promote in my opinion. So first choice would be promote if we have that. Market would be second choice. So we go down and we see that we do have promote. So our answer there would be C for number 37. Obviously, market is not an answer choice, so we don't have to worry about it. But let's say that you did come up with market and you didn't come up with promote, right? Obviously, you would see that market means very, very close to promote, and nothing else really means anything close to market, so then you would get promote anyways. But I'll go ahead and show you why A, B, and D are wrong as well right now. We wouldn't say to increase. Right, and I'm going to show you why real quick by going back to the text. Keep in mind, you can always go back to the text. It's very, very useful on the SAT reading section. We wouldn't say, will companies be able to increase their products? Because we're not talking about increasing their products. That's really vague, and it doesn't tell us exactly what we're doing. We want to be specific when we can on the SAT reading section. So anytime we can be more specific, we want to do it. So in this case, promote would be way more specific than increase because saying increase their products doesn't tell us if it's talking about customer sales or increasing the size of the product or the quantity sold or anything like that. So our answer there would not be increase. Accelerate, same thing. It's not telling us what, we wouldn't say accelerate their products. Okay, you can't accelerate a product. That would be if you were just to kind of throw a product and it moved faster. Okay, that doesn't work like that. So we would not use the word accelerate to describe boosting or marketing or promoting our sales of a product. Next, protect. Obviously, we would not protect product either. We're looking to promote it or market it. So our answer there would be C. So for most nearly means questions, obviously they are words and context questions, which means you always want to use the text. Whenever you have a most nearly means question, don't try to do it from memory. If you try to do it from memory or try to just guess synonyms, you're going to get it wrong. A lot of times they'll put synonyms as one of your answer choices just because they think that you'll pick it without going back and looking at the text, and the synonym will end up being wrong. So don't just pick the synonym. If you don't know what a synonym is, it's just a word that has a similar meaning to another word. Don't just pick the synonym. Go back and look at what the word actually means in the context of the sentence. That's the only way to get these questions right consistently. So you want to make sure that you're doing that. Also make sure you come with your own answer choice first so you don't get stuck between two or are swayed by other answer choices. Today I have an SAT reading tip for you that deals with data interpretation on the reading section. So to illustrate this tip, I'm going to use questions 19, 20, and 21 as an example from SAT Practice Test 8 on how I recommend approaching these types of questions. So this is the data chart that we're going to be using. I'm going to go ahead and go down to question 19 and we're going to start there. And as I go through these questions, I'll be kind of giving you my advice on how to approach these types of questions on the SAT. So we have question 19. According to the graph, social science studies yielding strong results were what? Well, in this case, since I see options A through D are all pretty short, what I'm actually going to do is I'm actually going to go to my graph and take a look at the strong results, or the science studies that yield strong results, and I'm just going to take a look at what I see in the graph, and then I'm going to go through A through D and take a look at the answer choices. So anytime that I see on a data interpretation question like this that my answer choices are pretty small like this, and I'm given one category, in this case only the studies that are yielding strong results, then I actually take a look at the graph and try to find a general feel for what the graph is showing about those studies yielding strong results, and then I'll run through my answer choices. So here's what I see. All right, I'll zoom out so you can see the whole graph. I see that for my strong results bar, I've got, it's 42% of the total. I see of those published in a top journal, that's going to be right around 20%. So we got 20% published in a top journal. I see that I've got of those published in a non-top journal, that's going to be roughly 40%, since it's from about 40% to 80%. And then I see of those unpublished but written, I see that that's going to be right around roughly, it looks like close to 30%, and then I see the unwritten, it looks like unwritten's only right around 5%. Okay, so unwritten's gonna be really small there. So the big thing I see here, 20% top journal, unwritten really small, and then we have right around 30% for the unpublished but written and the published and non-top journal. So I'm just gonna take a look, find an answer choice that fits that general idea of what that graph is showing. Okay, so we have unwritten over 50% of the time. No. Okay, we saw that it was strong publication and strong likelihood of being written in this category since it did yield strong results. Unpublished but written 50% of the time. Also not true. Option C, published in a top journal approximately 20% of the time. Yes, okay, that was that top part of that graph that went from 80 to 100. That's 20% of the time it's published in a top journal. So my answer there is going to be C. Option D says published in a non-top journal almost 80% of the time. That was false. That was right around 40% of the time. Okay, so answer for that one is going to be C. Big tip there, just make sure that you're going back to your graph if you need to make sure you get to the right answer. It's always okay to go back to the text and back to the graphs on the SAT reading section. Question 20, which of the following statements is supported by the graph? Okay, in this case, I see options A through D are really lengthy, right? So what I want to do here is you have a couple options on how to approach this. Really, there's the two options that I recommend. It doesn't necessarily matter too much which one you pick. You can go either way. So one thing that you could do is you could go to the graph and get a generalized feel for the graph, kind of see what it's pointing to, and then go through options A through D and find what's correct. Another option is you could take a look at A, read it, and then go check it with the graph, see if it's correct. Read B, read it, kind of get an understanding, go check with the graph, see if it's correct. What I generally prefer to do is I generally prefer to go to my graph first and just take a look at what it is, get a general feel for it, and then go down and take a look at what my options say. So in this case, I see strong results. They're really a lot more likely to get published in that top journal, right? As we see that, as we go down to these nil results, that top journal likelihood goes from 20% down to like 15, down to like 10, right? As pretty much I see a general trend here, right? If we look, we see things going in this direction, right? So we see the likelihood of something going unwritten increases as it goes from strong results to the null results. We see the likelihood of something being published in a non-top journal is also going down as we go towards those null results. So basically, something with strong results is far more likely to be written and published in a non-top journal and published in a top journal than those with mixed results and null results. That's really the pattern I'm going to be looking for in question 20. Okay, so we see option A, studies with mixed results were just as likely to be published as they were to be left either unpublished or unwritten. All right, well, let's go take a look at that if that one's correct. In this case, obviously that didn't show up right away as our answer, so we're just going to go take a look. I do remember that those with mixed results had a pretty good split as far as right down the 50 mark. So let's take a look. It looks like we do have that split at the 50 mark, and that is between being published versus unpublished. Okay, so we have unpublished versus published. We see it split at the 50 mark. Thus, those with mixed results are going to have an equal likelihood of being published as unpublished. So that's going to be correct for number 20. Okay, so in this case, we have 20. Answer there is going to be A, and I'll put it in black so you can see that it's not in red, because sometimes people think red means the wrong answer. So we have option A as our correct answer. Studies with mixed results are just as likely to be published as they were to be left unpublished or unwritten. Okay, that one's factually correct. Next up, we want to go down to 21, and just another quick side note on question 20. If you have a question like this and you got these data interpretation questions with really long answers here, I recommend going from A to D, just because oftentimes, in my opinion, I don't know, I haven't done like a full data analysis on this, but just from what I've seen on practice tests and from how it sort of seems to me, it seems that if they have really long, lengthy parts for the data interpretation question answers, that oftentimes the answers will lie in like A through C rather than being at D, because they know you have to read through all of them. Now, I haven't gone through and checked if that's actually true as to if it's more likely to be an A through C than D on these types of questions, but that's just my general feel. So I would recommend going A through D, but once again, that's just my general feel. All right, so now we got question 21. Which statement from the passage is most directly reflected by the data presented in the graph? So in this case, obviously you haven't read the passage, but I can give you a brief overview of the passage real quick. This passage was pretty much saying that if you have data that is likely to yield strong results, or that yields strong results, it's a lot more likely to be published. And they're also, yeah, that's pretty much all the summary that you need. I'm not going to bore you with all the details. Okay, so in this case, we're asked for which statement from the passage is going to be directly reflected by the data presented in the graph. Now, one thing I want to note on these types of questions, if we take a look at our graph, we know that the data that's represented, it's all about publishing and being written. So, once again, if you watched my video where I talked about finding evidence, okay, and finding lines on that, I talk about the use of keywords to figure out where to start in your lines. Okay, so in this case, since our graph is actually going to supply our keywords. Our graph is talking about things being published, right? The likelihood of things being published, as well as the likelihood of things being written. So those are the keywords that I'd actually be looking for in my lines here to know where to start if I didn't already know which lines there are. Now, if I already knew which lines this is supporting, I'm just going to go find those lines, and then I'm going to click those as my answers, right? Those would be obviously my answers. I don't have to go through the other ones because I already know where it is. But let's say that I forgot where it was. Let's say I don't know if it's in lines 30, line 33, 43, 52, 55. I'm not sure where to start. In that case, what I do is I use these keywords. Okay, in this case, they come from the graph, and they're going to be published and written, since those are what the graph is showing. It's showing the likelihoods to be published, likelihoods to be written. So in this case, I look at which one has my keywords. I see that that's going to be C. So that's where I'm going to start. I'm going to go take a look at lines 43 to 45, see if my graph supports it. So I go up, we got 43 to 45. I'll go ahead and highlight that so you can see it better. So we got 43, we have not unexpectedly, which just means expectedly. The statistical strength of the findings made a huge difference in whether or not they were ever published. And that is what the graph shows, because we see that the stronger the results that are yielded, the higher likelihood it is to be published, right? We can go ahead and show you that as well. Okay, we see that the likelihood of being published is going to be the black bar plus this dashed bar. Okay, so I'm just going to put some highlighter around it so you can see it. We see how high that is here versus it being very, very low in these other two. Okay. All right, so that's going to be our answer there. So big thing there is understanding with these questions where you have to find the lines and find the evidence. Use the keywords if you don't know where to start. Obviously, if you know where to start, you don't have to use the keywords, but if you don't, that's going to be where you start. Now, you can't always just rely on the keywords. You can't find something with a keyword and just pick it as your answer because it has the keyword. You should always go back to the lines and make sure that it is indeed your correct answer, just in case. But it does provide you a great place to start, because now that you've seen that C is the correct answer, you don't have to read B, you don't have to read A, and you don't have to read D. So that's going to save you a lot of time on the reading section. So hopefully this video is helpful. Today I have an SAT reading section tip for you that deals with paired questions. So in this case, a paired question is going to be question 33 with its evidence question 34. So the first question, you have to answer that, and your second question will ask you to find the lines that support your answer to the previous question. So in this case, I'm going to use questions 33 and 34 to illustrate as an example, and then also questions 42 and 43 to illustrate as an example. So this is going to be from SAT Practice Test 5. We see question 33, we have to answer that one, and then question 34, we're told which choice provides the best evidence for the answer to the previous question. So let's go ahead and take a look at 33. I'm not going to read the whole passage because that would kind of waste our time here, so I'll just kind of give you a summary of it as I go through question 33, as well as the tips that you need to know to answer these types of questions on the SAT reading section. So, the author of the passage suggests that crowds may be more effective at what? Okay, what I'm going to do here is I'm going to go ahead and tell you the correct answer. The correct answer here is going to be C. Okay, the author of the passage, in his text, he suggests that crowds are more effective at arriving at accurate quantitative answers than producing valid qualitative judgments. Now, I also want to go through A, B, and D and tell you why those ones are wrong real quick. For A, B, and D, all three of these, they're all wrong for the same reason in this case, and that's that the author never makes these claims, right? He never says that creating controversy or that crowds may be more effective at creating controversy than examining an issue in depth. He never says that, therefore it's unsupported and wrong. Any answer choice that can't be supported by the text is wrong. So A is wrong. B, reinforcing members' ideas rather than challenging those ideas. Once again, the author never makes that claim. Okay, so that's unsupported by the text. Okay, unsupported by text. There's no possible way we could support option A or option B or option D. In this case, all of them are wrong because none of them could be supported by the text, and they're all really kind of off in that there's really nowhere that we talk about anything with A, B, or D. So they're all pretty obviously wrong, okay? And they're obviously unsupported by the text since we would have no evidence to support it with. Okay, so in this case, obviously, if you had read the passage, you would see that obviously C would be the correct answer. I'm not going to go back and read the whole passage because I'm trying to just illustrate this as a tip and trick. But once you see, you get your answer C, you have arriving at accurate quantitative answers rather than producing valid qualitative judgments. So now here's where the big tips come in, and that's with these evidence questions. So with these evidence questions, what you're going to want to do is the first thing you want to think is, where's my evidence for that previous question, right? And for the question that you answered previously, you should have evidence for it anyways, right, already in mind, because any answer choice that you pick on the SAT reading section, you should be able to support with the text, because if you can't support it with the text, then you're probably wrong. Okay, all answer choices have to be able to be supported by the text for the SAT reading section, or all correct answer choices have to be. So you should already have an idea of what your evidence is going to be. Now, let's say that you know where your evidence is going to be, then just go back, find it, and then you'll find your answer. Now, let's say that you don't quite exactly remember what lines it was in, right? You're not sure if it was in line 9 or in 17 to 20 or 11 to 14 or 25 to 28. This is where my tip is going to come in. Now, we know in our previous question that our answer was that we are the crowd is better at arriving at accurate quantitative answers than valid qualitative judgments. Well, quantitative answers is going to involve numbers. So now if I take a look at my options here, I see I have the word number at the end of 11 to 14. Okay, so that's something dealing with quantitative numbers, right? Or quantitative answers coming from the crowd. Okay, so that's what I'm going to call, we can call it a keyword, right? Really what you just need to understand is that it's an indicator word, right? It's indicating that it's quite possible that these lines are going to contain the best evidence, right? So in this case, the word that I'm looking at is number, since I was talking about quantitative things in my answer. So that's where I would start if I didn't already know where my lines were going to be. These would be where I'd start. And then what this is going to do is this is going to help me, because if I go to lines 11 to 14 now, if I go to lines 11 to 14, I see it says, your guess is probably going to be far from the mark, whereas the average of many people's choices is remarkably close to the true number. And if we get some more context on this by reading back, we see that sometimes the crowd really is wiser than you. The classic examples are guessing the weight of a bull or the number of gumballs in a jar. Your guess is probably far from the mark, whereas the average of many people's choices are remarkably close to the true number. So that's showing that crowds are good at producing solid quantitative answers there, and so we know that that'll be our answer. Okay, so that's going to be lines 11 to 14. All right, so that's the big tip here, is that if you're not quite sure where the lines are, okay, say that you have a good idea of the evidence, but you don't quite remember what lines it were in, try to look for a keyword from your previous answer choice. In that case, it was talking about quantitative numbers, thus we look for the word number. Okay, now if I hadn't seen the word number, then the next thing I would look at is the word value, okay, because value could also indicate potentially something that's quantitative, but number would be more likely to indicate a quantitative thing. That's why I started there. And then obviously when I went to those lines, it clearly gave me the best evidence I could have, thus I selected B, and I wouldn't even go through and read C, D, or A, because I know that B has to be correct since that supported my previous answer.